Yeah.
What's the AP test?
May 14th. I think it's a Tuesday at 8 o'clock in the morning. Okay? All right, make sure you have a calculator today. We have, I think, just 2 more examples to go over for this section. Before we get started, we're going to have a brief moment of silence for this sad, sad day. Because when we get done with these 2 problems, we are officially done for the year. No more notes, no more sections. This is it. So, congratulations. Bless you. Bless you.
Let's have 11 minutes of silence.
11? No. It's not even going to take us 11 minutes to do these last two problems. All right. So yesterday we were looking at the volume of an object that has an area as its base. Okay. For instance, at the top of the page we have this area of R, and we're trying to figure out what the volume of the solid would be if we had particular shapes as our cross sections. Like we would cut it and open it up and take a look at the shape that we have. I'm pretty sure we finished the first 4 at the top. Is that right from yesterday? Okay. So the 4 from yesterday that we did were the equilateral triangle, isosceles triangle, semicircle, and squares. Those were the 4 shapes of cross sections that we paid close attention to when we were taking the notes at the very beginning. But there are other cross-sectional shapes that you could have. For instance, you could have a rectangle. If you were to slice something open and take a look at it, it could look like a rectangle. So we're going to check those 2 out at the bottom. Just because these aren't the shapes that we discussed previously doesn't mean we can't figure out what the volume might be. Because everything we've been talking about for at least these volumes is that we have to integrate the area to get the volume. So let's see if we can figure out the area of these rectangles or these rectangular cross sections. So for part E, we have a cross section that looks like a rectangle. Maybe we'll just draw in that shape. And we know the height is twice the length of the base. Now the base of the rectangle, I'm going to try to draw this in at the top of the page. The base of the rectangle is what would land in the area region itself. Okay, we're actually going to do this tomorrow with the Play-Doh activity. I think I let you guys know. And the rest of the rectangle would stand up vertically from there. So you kind of have your region that's flat on a piece of paper, and then your rectangle is going to kind of stand up in that region. So we have this rectangular cross section. Notice how the base of the rectangle touches the top function and the bottom function. So we can go ahead and label at least our picture down here as f of x minus g of x, where f of x is the top function and g of x is the bottom. Okay, it always kind of comes back to top minus bottom. If we know the height is twice the length of the base, how can we label the height in our little picture? What do you think, Josh?
Wait. The height is twice?
Twice the length of the base.
So 2
times? 2 times, yep. F of x minus g of x.
Yeah, but it looks shorter.
It's not drawn to scale. We'll just say that. Okay, it's not drawn to scale.
Because I was about to throw 1/2 out there.
Yes, okay, so I understand that, but it's not drawn to scale.
Okay.
Okay? So if this is how we can label our rectangular cross section based off the information, what would the area formula look like for this particular rectangle? Yeah?
Since everything's being multiplied, we can put 2 times f of x minus g of x squared.
There we go. So the area for a rectangle is base times height, or length times width, whatever phrasing you want to use. So we'll have f of x minus g of x times a 2 f of x minus g of x. So f of x minus g of x is being multiplied together. That's where the squared's coming from. And notice how we have the 2 out front. So if this is the area for the rectangular cross section, we'll have to integrate that area to help us find the volume. Now, in the particular region at the top of the page, the top function was the trig function, and the bottom function was the cubic. So if we're subtracting the cubic, we'd have to subtract every part of it. That means all the signs would change. So this kind of leads us into noticing how the 2, okay, because we were having a height that's twice the length of the base, is that multiplier factor. Okay, when we talked about, I'm going to move the page up a bit. When we talked about equilateral triangles, our multiplier was square root of 3 over 4. For semicircles, it was 1/8 pi. For isosceles triangles, it was a half. For squares, our multiplier was 1. Okay, in this case or example, our multiplier is 2 because it's double or twice the length of the base. For the region R at the top, we're going to have the bounds 0 to 2. That's where the region begins and ends. So from there, it's just some calculator work to help us figure out the volume of this solid. Did we get it? Yeah.
19.957.
19.957. Perfect. All right. So the very last one, cross sections are rectangles whose height is 1/3 the length of the base. Instead of having to draw another rectangular example, do you think we can make a connection and immediately write out our volume integral? What might it look like? Yeah.
Volume is the same thing that we have over for volume of the previous section.
Mhm.
So replace the base 2 with 1/3.
With a 1/3. Okay, that's our multiplier in this case. All right, so calculator work from there. We'll find our volume. Good, Ryan?
3.326.
3.326. Can we get those two values on our calculator? So far, so good?
Mm-hmm.
Perfect. All right, that's it, guys.
Wow.
Congratulations. You survived your first year of calculus.
136 days in the making.
I know. So we have, well, actually, I think it was more than that because,
Well, that's what the homework said.
yeah, that's what the homework says. But
136 days.
But it's more than that because we took our time with some of the sections. So from here on out, we're going to have our activity day tomorrow, free response day on Friday, and then from then until May 14th, which is test day, we're going to be doing review practice problems in here. Okay, and then after tests, we're most likely going to come back and look at the 2 partner quizzes from this unit and the unit test. Okay. We are done with this section, so you can pack up if you wanted to, but I did have a quick question for you.
Okay.
I know you might not have it, or I don't know if it's in your locker, but do you have any samples of the 3D prints that you do on you, with you?
I don't know if I have any on me.
No,
I might.
that's okay.
Is it okay if I do more?
That's fine.
Okay, I'll see you later.
See ya. Good luck.
Yeah. Thanks for the calculus.